Hello guys and welcome to another edition of this video. Here we're going to take GCE 2018, which is going to be differentiation part of it, and it is question 3. So get the question in the link below. It says differentiate a ln 1 plus x squared ordered on x to the 5 plus, and then b says sine squared ordered x plus 1. So let's get started with that. So let's take the first one, that telling us to differentiate with respect to x. So looking at it, we see that it's a quotient. That means we're going to use the quotient rule, and starting with it, we're going to just assign this top to be u and this bottom to be v, where we're going to use our formula dy on the x equals to v du on the x minus u dv on the x ordered on v squared. So that's the formula we're going to be using. Okay, so we have assigned this x to the 5 to be v and this top function to be u. So let's firstly get what we're to find. We're to find u on the x, we're to find the v on the x, where we have u and we have v. So finding du on the x, which is simply going to be the derivative of this top function, and which is a logarithmic function. That means we just differentiate the inner function, and that's going to give me 2x, and write back the function 1 plus x squared. Now let's differentiate to find v. That's going to be dv on the x, which is going to be a polynomial differentiation 5x to the 4. So we have all what we need to have this question done. So let's write it down. Dy by the x is simply going to be v. What's v? That's x to the 5 into du on the x. What's du on the x? 2x on 1 plus x squared minus u. What is u? U is ln of 1 plus x squared. And what is dv on the x? dv on the x is 5x to the 4, and all this divided by x to the 5 ordered squared, which can be further simplified as 2x to the 6 on 1 plus x squared minus 5x to the 4, that is ordered bracket, ln into 1 plus x squared ordered on x to the 10. So we can simply leave it like this or further simplify. That is our dy dx, so it's equals to this. So okay, we're going to continue with the second part of this equation, which says we should differentiate sine squared ordered x into x plus 1. So we're going to let it y be equals to sine squared ordered into x plus 1, and we're going to differentiate it. So we're going to use the technique of differentiation, which we have done before. So just be vigilant to pick out the technique. So what are we going to do here? We're going to simply let u to be equals to sine x plus 1. And so if we differentiate du on the x, if we have du on the x, we're going to simply have a cos bracket x plus 1. So now we write back the equation y equals to what? We're going to rewrite this equation, but we have said let u be equals to this, so it's simply going to be u squared. And so differentiating dy on the u, I'm going to have 2u, but u is equals to sine x plus 1. So I'm going to have this equals to 2 sine x plus 1. Now dy by dx is given by dy on du times du on dx. Now which is going to equals to dy on du is given by 2 sine x plus 1 times what? Du on dx. What's du on dx? That's going to be cos in bracket x plus 1. So this looks familiar. This stuff looks familiar, like a certain trigonometric expansion of sine 2a. Let's just say sine 2a, which is given as 2 sine a cos a. Well, let's imagine in the case where this x plus 1 is equals to a. So we could simply say that this derivative is equals to what? Sine 2 in bracket x plus 1. That is it. And that is the derivative. Thanks for watching, and don't forget to subscribe.